Okay, so now we move to the next part of the lesson, section 4.2. So acceleration of an object moving in a horizontal circular path. Okay, so directly I'm going to go with the equations because the proof of these equations are not necessary. All you require is to know the equations and how to apply the equations. Okay, so I will directly go with the required equation. An object moving on a circular path with constant linear speed v and constant angular speed omega has acceleration. Okay, look. So we are talking about some kind of an acceleration but, towards the center of the circle. So basically, if you have an object that's moving in a circular path, there is always going to be an acceleration directed towards the center of the circle. Okay, always there's an acceleration towards the center of the circle. And this is called the centripetal acceleration. And there are two equations that we can use to calculate the centripetal acceleration. So the derivation of them is not required. Okay, so the centripetal acceleration, the first formula we use is r omega square. Okay, so this gives the this is used to calculate the acceleration towards the center. So acceleration is r omega square, the centripetal acceleration. The other equation is v square over r. So you will use these equations as appropriate in the sum. Okay. So centripetal acceleration is measured by two equations, r omega square, and the other equation is v square over r. Actually, you can from one equation you can derive the other because you basically they have substituted v equal r omega into one to get the other, right? And so basically omega is v square over r square, and if you substitute that, you can get the other equation. Anyway, all you need to know here is to remember these two equations. That's it. Okay, so these are the two main equations that we use that are used to measure the acceleration towards the center. Okay, so we'll move on to exercise 4b. Question number 1, and they say whenever a numerical value of g is required, take g equal to 9.8 meter per second square. Okay, so they say a particle is moving on a horizontal circular path of radius 16 centimeters. Once again, they are, just be cautious, it's 16 centimeters with a constant angular speed of 5 radians per second. So your radius is 16 centimeters. Or 0.16 meters, and the constant angular speed omega is 5 radians per second. Calculate the acceleration of the particle. So it's simply acceleration. There were two equations, r omega square and v squared over r. So we go with r omega square. So radius is 0.16 into omega square is 5 square. Isn't it? So how much is the answer? 0.16 into 25, right? 0.16 into 25, that's 4. That's 4 meters per second square. So your unit acceleration, centripetal acceleration will have the unit meter per second square. Okay, so let's move on to another question now. Okay, so question number 3, they say a particle is moving on a horizontal circular path of radius 3 meters. Given that the acceleration of the particle is 75 meter per second square towards the center of the circle, find the angular speed. Okay, so these questions are basically given to make you familiar with those two equations. Okay. Okay, so they have given you the radius, that's 3 meters, and the centripetal acceleration. The acceleration towards the center is 75 meter per second square. They're asking you to find the angular speed. So what's the equation? There are two equations, acceleration, centripetal acceleration v square over r, and centripetal acceleration is r omega square. Since they ask you to find the angular speed, we will go for centripetal acceleration equals to r omega square. So centripetal acceleration is 75, radius is 3 into omega square. 75 divided by 3, that's 25, right? 25 equals omega square, and omega equals root 25, which is 5. So 5 radians per second. So omega is equal to 5 radians per second. Okay. So in part B, they ask you to find the linear speed of the particle. So to get the linear speed, either you could again use acceleration equal the second equation, v square over r. So that can be used, or we can equal, you also use v equal r omega, the very first equation. So anything is fine. You could use acceleration is v square over r, or you could use velocity, linear speed is equal to r omega. So linear speed is what I'm trying to find. Radius is 3. Omega we just found as 5 radians per second. So we will be 3 into 5. So that's going to be 15, right? That's going to be 15 meters per second. Okay. Okay, so next I chose question number 7. Okay, so we'll go through question number 7. One end of a light inextensible string. So inextensible means the string doesn't stretch. Okay. So one end of a light inextensible string of length 0.15 meter is attached to a point P of mass 300 grams. Okay. Remember, this is mass. Okay. Not weight. So there are those small things make a difference. So it's mass, which means this is in grams. Okay. 300 grams. The other end of the string is attached to a fixed point O on a smooth horizontal table. P moves in a horizontal circle center O at a constant angular speed 4 radians per second. Find the tension in the string. Okay, so basically you have the point O and you're on a table. So this is the table. You do, just draw a simple diagram. And then the center O, and you have a particle moving in a circular path on the table. Okay, so you have this particle moving in a circular path. Okay, so they say one end of a lightning extensible string of length 0.15 is attached to a particle P. So P mass 300 grams. Of course, I can't keep the mass in grams. So mass will be 300 grams is 0.3 kilograms. Okay, and then you must realize the length of the string is going to be the radius, because the length of the, I mean, we are going to rotate this around this point O, and the length of the string is what's going to be the radius. So radius is 0.15 meters. The other end of the string is attached to a fixed point O. So this is the fixed point O. On a smooth horizontal table. P moves in a horizontal circle center O at a constant angular speed 4 radians per second. So omega is 4 radians per second. Find the tension in the string. Okay, so guys, this is where we start to use some applications of the centripetal force. Okay, look, so you have now obviously when the particle is moving in a circular motion, okay, when the particle is moving in circular motion, I think you can see that the string, this string is fully stretched, right? When you're when the particle is moving in circular motion around the table, you need to realize that the string is fully stretched, and you can see that there is a tension acting on the string, right? So previously I was discussing to you something called centripetal acceleration, right? So centripetal acceleration is the acceleration of the particle towards the center. And similarly, we also have something called the centripetal force. So centripetal force is what we call as the force that is acting towards the center. Okay, so centripetal force is the force acting towards the center. Okay, so in this case, centripetal force, the force acting towards the center. Okay, so what you need to do here is, you have to identify what is the centripetal force. Okay, so the centripetal force is not a force by itself. Okay, it's not a force on its own, but it is some other force that is actually over there in the sum. Now, in this particular question, looking at the sum, who is the force that is acting towards the center? What is the force that is actually acting towards the center? You can see it's the tension, right? Can you see it's the tension that is acting towards the center? Therefore, in this case, the centripetal force is going to be the tension. Okay. So we apply something called, we are going to apply the equation F equal ma, Newton's second law. So we're going to apply F equal ma, and they are going to apply this towards the center. So it's going to be, we are going to model the centripetal force and the centripetal acceleration. So centripetal force here is going to be tension. Centripetal force here is going to be tension, because that is the force that's acting towards the center. Okay, equals mass. Mass is 0.3 kilogram into acceleration. So acceleration is not just any acceleration, but the centripetal acceleration. So for centripetal acceleration, either you go with v square over r, or you go with r omega square. So I think I have the omega value and the r value. So I'll go with r omega square. So we have here tension equals 0.3 into radius is 0.15 into omega square is 4 square. So tension equals how much is it? 0.3 into 0.15 into 4 square. So I get tension is 0.72 newtons. So this is the tension in the string. And this is how we, this is the beginning of the sums where we come to deal with centripetal force. So this is really important. So whenever you have a particle moving in a circular path, remember there will be what? Always a force acting towards the center. And this force could be, different, it could be, now in this case, it's tension. Okay, so sometimes you might even have components of some force acting towards the center. It could be normal reaction, it could be weight components. So when we go with more questions, you will come to realize how to identify the centripetal force. Okay, so in this question, it is simply the tension that's acting towards center, and then we apply F equal ma. And remember, for acceleration, you must use the centripetal acceleration equations, either r omega square or v square over r. Okay. Okay, so next I'll move on to question number 10. Okay, so they say a particle P of mass 15 grams. Okay, so again, mass. Okay, so therefore it should be grams. Okay, 15 grams rests on a rough horizontal disk at a distance 12 centimeters from the center. The disk rotates at a constant angular speed of 2 radians per second, and the particle does not slip. Calculate the linear speed of the particle. Okay, so that we can calculate the linear speed by using the equation V equal R omega. So V is the linear speed, R radius. I think you can see what's the radius here, right? Because you have a rough horizontal disk and your particle is placed 12 centimeters away from the center. So this is the disk. Okay, so this is the disk and you have the particle. So the particle is, you could keep it on the edge or anywhere. Anyway, the thing is the particle is 12 centimeters away from the center. That's all. You could just keep it anywhere, but just give this distance as 12 centimeters. Okay. Okay, so calculate the speed of the particle. So the radius is 12 centimeters, but we don't write it in centimeters. We write it in meters. So 12 centimeters is 0.12 meter into omega. Omega is 2 radians per second. So V equals 0.12 into 2 is 0.24. 0.24 meters per second, right? Okay, so now you need to realize, since this particle is going to, this is a rough horizontal disk, and this disk is, they say the disk is rotating. It's not the particle that's rotating, but it's the entire disk that's rotating. So your particle is sitting on top of the disk. And you see what's happening? So there's a disk that is rotating around. The disk itself is rotating around its center. And then you have a particle which you have just placed on this point. So you need to realize, like, I think you can understand that if you try to go at a certain speed, like trying to increase the speed, there will come a point where this particle will slip out, right? It will completely go out because if the speed is increasing. So the thing is, what's keeping this particle intact? Okay, so they are saying it's a rough horizontal disk, right? So if it's a rough horizontal disk, the only thing that's preventing this particle from, flying out when the disk is rotating is what force? In this case, there is a force always acting towards the center. That's what's keeping this particle intact. So if the when the disk is rotating, okay, the force that's holding this without making it go out, without making it slip out is what? It's the friction force. In this case, it's going to be the friction force. So you need to understand in this case, the centripetal force, is the friction. The centripetal force is the friction. Okay, it's the friction that holds this object to avoid it, from, slipping out, from flying out. Okay, so you need to understand that the when this spins, okay, so you can, like, think in your head, if it spins fast, this object will go out, right? So there has to be some kind of a force that will hold this. So the force that's holding this intact and not making it go out, it's the friction force that's holding this. So friction is going to act towards the center. Okay, friction will act towards the center, and they're asking you to find the force due to friction acting on the particle. So basically what we apply here is we apply F equal ma, and we are going to apply F equal ma towards the center. So what's the centripetal force now? In this case, the centripetal force is the friction force. Okay, so in this case, centripetal force is the friction force. And then the mass is 15 grams, means 0.015 kilograms. Mass must be in kilograms. And the acceleration is a centripetal acceleration, because we are working with centripetal force. The acceleration should be centripetal acceleration. So centripetal acceleration, you can go with either r omega square or v square over r. So either one of them is okay. So friction is equal to the centripetal force is the friction, 0.015, radius is 0.12 into omega square. So omega is 2. So 2 square. So you type everything in the cap, 0.015 into 0.12 into 2 square. So that gives me 7. That gives me 7.2 into 10 to the power minus 3, or 0.0072 newtons. Right, 0.0072 newtons. This is the friction force acting on this particle. Okay, so question number 13. A car is traveling around a bend on a flat road, which is an arc of a circle of radius 80 meters. The greatest speed at which the car can travel around the bend without slipping is 40 km per hour. Find the coefficient of friction between the tires of the car and the road. Okay, so basically, once again, we have a circular motion happening here. So a car is moving around in circular motion. So basically, what we need to do here is, okay, so you have a car. I'll draw the car as a particle. So the car is traveling on the road. Okay, so it's traveling around a bend. The car is traveling on a bend. Okay, so there is a bend. It's a circular road. Okay, and then so you need to mark the forces that is acting on the car. Okay, so what are the forces acting on the car? So they are saying the first thing is let's mark the information. Okay, so they're saying the radius is 80. Let's mark that radius is 80 meters. So this is the radius. The greatest speed at which the car can travel around the bend without slipping. The greatest speed, which means they are saying like this is the maximum speed that you can go, is 40 kilometers per hour. However, the unit here is going to be problematic. We need to fix the unit because we need the speed to be in meters per second. So shall we convert 40 kilometer per hour to meter per second? So 40 kilometer in 1 hour. So 40 kilometer to meter is 1000 meters. 1 hour to 1 second, 1 hour 60 minutes into 60 seconds. So multiply everything down and divide. So 40 into 1000 divide by, 60 times 60. So I get here 100 over 9. 11.11. 100 over 9 meters per second. Is that okay? 100 over 9 meters per second. Okay, so now I have the speed in meters per second. So it's time to mark all the forces, and we need to specially identify the centripetal force. Now the car is moving in this circular path. Okay, so it's moving on the road. So the car is moving on the road. I want all the forces acting on the car. So what are all the forces? The first thing is, if you are going at the greatest possible speed, that you are able, that the car is able to achieve without slipping. So you need to realize that obviously when you're going in a circular path, the higher the speed, the tendency is that you slip outside, that you go outside of the path. So in that case, what's going to keep this in the circular path? What is the force that's keeping it in? It's the friction force, right? So it's the friction force. So that's what they're saying, the coefficient of friction should, they're asking you to find. Anyway, it's the friction force what will hold the car in this circular path. And then what other forces are there? I think in the previous questions, I did not mark the weight or the normal reaction. Actually, because weight and normal reaction are perpendicular. Basically, they are vertical forces. So since we are working with horizontal circles and horizontal circular motion, these vertical forces don't make much of an impact. That's why I did not mark it on any of the previous questions. But over here, since we're going to find the coefficient of friction, the mu value, F max is equal to mu r. So I will need to know the normal reaction. Okay, so the car is on the road. So the other forces acting on the car are, you have the normal reaction acting upwards, right? Normal reaction acting upwards, and the weight of the car acting downwards. So weight of the car, have they given us? No. So we'll write it as mg. Weight of the car is mg. Okay. So I will take the full force the full diagram into account here. But remember, the centripetal force is only the horizontal force. It's only the friction force. Okay, the normal reaction and the weight, they are vertical forces, and they don't make an impact towards the centripetal force. They don't make an impact in the horizontal circular motion. Okay, so one thing you need to realize is, while the car is moving in this circular motion around, while it's going in the circular motion, the horizontal circle, the normal reaction and mg, basically the vertical forces, are in balance, because the vertical forces, the particle has no tendency of moving up or down. So vertical forces are going to be in balance. So R is going to be equal to mg. So you can write here by vertical equilibrium. So vertical equilibrium, R will be equal to mg. Okay. And then let's apply F equal ma towards center. Next one. The next thing, I will apply F equal ma towards center. So what is the centripetal force? Centripetal force is the friction. Okay. And in this case, we have the maximum friction, because they have said they have given the maximum speed. The maximum speed of the car means you have achieved the maximum friction, because this is the maximum friction that the particle, that the car can have, that is between the car and the road. Okay, so the maximum friction is equal to m into a. So mass is unknown, acceleration. So I think we can go with r omega square or v square over r. Since we know the linear speed, we'll go with v square over r. So the maximum friction is equal to mass is unknown. V square is 100 over 9, right? V is 100 over 9. V square is 100 over 9 square into radius. Radius is, I'll write 1 over. Radius is 80 meters, right? So I V square into 1 over R. I put the V square value here into radius. It's 1 over, the radius is 80. Okay, so this is the friction force. Okay, you can calculate that or leave it at this point, and you can apply now, find the coefficient of friction by using friction is equal to mu r. So maximum friction is equal to mu r. Maximum friction is mass into 100 over 9 square into 1 over 80 equals mu r. So mu is what we're trying to find. Normal reaction is mg. Can you see? Normal reaction is mg. And so you can cancel out the m, and we can get the mu value. So mu is equal to 100 over 9 whole thing square into 1 over 80, and the g also comes down, 1 over g. G is 9.8. So remember, whenever you use g as 9.8, you normally give the answer either to 2SF or 3SF. Okay, so let's get the answer. So correct to 3SF, the mu value will be 0.157. Okay, so this is the answer. Okay, so this is your mu answer. Okay, I hope this is clear with everyone.